All right, welcome to this discussion of adding and subtracting rational expressions 2.0. And in this case, we are going to be looking at adding and subtracting fractions and or rational expressions that do not have common denominators. So we're going to have to come up with common denominators for either 2 terms or 3 terms. So let's jump into this discussion. All right, so I'm looking at the first example, and it's just a fraction. And I see I've got a denominator of 12 and a denominator of 8. Obviously, these are not the same value. So I want to adjust these fractions so that they have the same value in the denominator. So I'm going to be thinking about a least common multiple or least common denominator of those values of 12 and 8. Okay, so thinking about this, 8 is not a factor of 12, right? So I can't just do something to the fraction with 8 as the denominator and turn it into 12. All right, but I can think about, all right, what is, if I'm thinking about multiples of 12, the next multiple of 12 is just 12 times 2, which is 24. And 8 does go into 24. All right, so let's turn our denominators into 24. What that means is I'm going to need to multiply each of the fractions by whatever's going to cause the denominator to become 24. And I will do that to the numerator and the denominator. So let's start with the first one. We've got 7 divided by 12, and we want to turn the denominator into 24, which means I'm going to multiply this by 2 and then this by 2. I can do that because this piece is just multiplying by 1. It's not changing the value at all. All it's doing is changing the form. All right? All right, and then we're going to think about the second piece, which is 9 over 8. And again, I want to turn that denominator into 24. So in this case, we're going to multiply that by 3 over 3, right? Because, again, this is 1. And that's going to give me a denominator of 20. All right, so let's go ahead and multiply and simplify. All right, so the first piece, we've got 2 times 7, which is going to be 14, and that's over 24. And from that, we're going to subtract 27 over 24. And since we have like terms, we're just going to take that 14 minus 27 and place that over 24. Now, of course, 14 minus 27 is going to be negative 13. And so we will end up with negative 13 over 24. Now, I know that most of your calculators will do this for you. However, when we're thinking about rational expressions, when we come down here, most of your calculators will not do that. And unless you understand what we're doing in these types of problems, you're not going to be successful when we're talking about these types of problems. Okay, just saying. Okay, so if I'm looking at this second example, I have denominators of 10, 6, and 15. Thinking about what are common denominators here. 10 is not a factor of 15. 6 is not a factor of 15. So what we are thinking about will be, let's think about multiples of 15. 15 times 2 is 30. Is 10 a factor of 30? Why, yes it is. Is 6 a factor of 30? Indeed it is. And so that will be our least common denominator, which is going to be 30. So I'm going to take and turn each of those fractions into a fraction with a denominator of 30. Let's do that. So we have 13 over 10 To that we're going to add 5 over 6. And then from that we're going to subtract 9 over 15. Now notice I left some space because I know I'm going to make some changes to those fractions, right? What will I have to multiply that 10 by in order to make it a 30? Of course, that's going to be 3. What will I need to multiply this 6 by to make it a 30? Of course, that will be a 5. So we'll have 5 over 5. And then what will I need to multiply the 15 by to make it 30? That will be 2 over 2. And now we're ready to multiply and simplify. So here I have 39 over 30 plus 25 over 30 minus 18 over 30. And so when we do that, what we really have is just 39 plus 25 minus 18 all over 30. And let's see, what would that end up being? 39 plus 25, that's going to be 64. 64 minus 18 is going to be 46. And so we would end up with 46 over 30, which can be simplified because these are both even numbers to 23 over 15. All right, so now let's apply these principles to these rational expressions. In this next example, I have a denominator of 9a. And in the second term, I've got a denominator of a squared. This is 9 times a, and this is a times a. So what do you think our least common denominator might be? Well, it's definitely going to have a 9 in it, right? And we definitely need to have the power of 2 in there. So our least common denominator is going to be 9a squared. All right, so let's make the adjustments we need to. So we have 4 over 9a, and from that we're going to subtract 1 over a squared. For the first term, we're going to need to multiply this by a over a, and that's going to give you a 9a squared here in the denominator. For the second term, we're going to multiply by 9 over 9, and that's going to give you 9a squared in the denominator there. All right, so multiply and simplify. We're going to end up with 4a minus 9 all over 9a squared. Looking for some common factors all the way through, and I don't see a single thing. So we're just going to leave it like that. All right, in this next example, notice that the denominators look very similar, but they're not exactly the same. Okay, we have b minus 3 and 3 minus b. Well, what that really means is we can take one of those and turn it into the other by multiplying it by -1. If I do that in the denominator, I'm also going to need to do it in the numerator. Okay, so what we're going to do is we're going to express both of our initial rational expressions, and we're going to change one of them. And it doesn't matter which one you change, but we're just going to remember that we're going to multiply one of them by -1 over -1 in order to change that denominator to what we want it to be. No pun intended, those are b's. All right, so we have b squared over b minus 3 minus -12 over b minus 3. And now we're ready to put those things together. And we have b squared minus -12 will be plus 12 all over b minus 3. Okay, b squared plus 12 all over b minus 3. For this example, I noticed that I have a trinomial as a denominator here, and a binomial as a denominator here. What I don't see very clearly is if there are common factors, and in order to do that, I'm going to need to factor both pieces. So let's go ahead and factor this first piece. We can say that this is going to be t plus 3 times t minus 1. And then in the second piece, we can say that this is going to be 7 times t minus 1. So notice that there are 3 different types of factors. We have the t plus 3, we have the t minus 1 that occurs in both of the pieces, and we have a 7. So my common denominator is going to have actually one of each of those. So my common denominator, LCD, is going to be 7 times t minus 1 times t plus 3. So we'll have to adjust each of the denominators to look like that. So let's see what that will look like. So we're going to have 4 t minus 5 over t plus 3 t minus 1. And to that we're going to add 19 over 7 times t minus 1. Okay, now looking at the first piece, the first expression, I have a t plus 3 and a t minus 1. I'm lacking the 7 piece. Okay, so I'm going to take and I'm going to multiply this expression by 7 over 7. And for the second expression, I have a 7 and I have a t minus 1. What I don't have is a t plus 3. So I'm going to multiply this piece by t plus 3, t plus 3. Okay? And so now what we end up having, in the denominator, we have 7 times t minus 1 times t plus 3. From this first expression, we have 7 times 4t minus 5. From this second expression, we have plus 19 times t plus 3. We're going to clean up that numerator a little bit and combine some like terms. So we're going to distribute this 7 through. We're going to have 28t minus 35. And then we're going to distribute that 19 through. Plus 19t plus 57. And that's all going to be over 7 times t minus 1 times t plus 3. You can just keep it in factored form. Then we're just going to combine some like terms in the numerator. And we'll have 28t plus 19t. And that's going to end up giving us 47t. And then we'll add those constants. I've got negative 35 plus 57. That's going to give me plus 22. And so we'll have 7 times t minus 1 times t plus 3 in the denominator. And that will be our final answer. All right, one more to go. This one is actually a little bit easier than the one above it. All right, so looking at these 3 pieces, we have 3 different denominators. We want them to all be the same. No factoring is available to us here or here. But in this third piece, we notice that this can be written as c times c plus 1, which happens to be the product of the other 2 denominators, which means that will be our least common denominator, c times c plus 1. Let's see what we can do here. We've got 5 over c minus 4c over c plus 1 plus, we've got c times c plus 1 in this last expression and 2c minus 1 as the numerator. Now, it's always good to keep it in factored form, especially when you are creating the revised versions of these expressions, okay? So if our least common denominator is c times c plus 1, then in this expression, we're going to need to multiply this times c plus 1 because I already have the c. And in this expression, I've got the c plus 1, so I just need to multiply it by c. And in this last expression, I have both pieces. I don't need to adjust it at all. So let's take this 5 and distribute it through to both pieces. And I'll have 5c plus 5 minus, I've got 4c squared in the numerator of this second expression. And then I've got plus the third expression, which is 2c minus 1. This is all over c times c plus 1. Let's take that numerator and combine some like terms. We have negative 4c squared here. Let's combine the c terms, which is going to be plus 7c. And then let's combine the 5 and the negative 1. We'll have a positive 4. And that's all over c times c plus 1. And that is all she wrote for that one.